Constructing a confidence interval. You randomly select 36 cars of the same model that were sold at a car dealership and determine the number of days each car sat on the dealership's lot before it was sold. The sample mean is 9.75 days, about 10 days, with a sample standard deviation of 2.39 days. Average is 2 days. Question says, construct a 99% confidence interval for the population mean. What's the population average number of days the car model sits on the dealership's lot? So we are basically forming a confidence interval. What are the steps? Which step we should take? Remember that when you have a confidence interval question for the average, for the mean, you have two options. The first option is to check to see if sigma is given to you and follow these steps using ZC, or check to see if sigma is missing, population standard deviation is missing, and follow the steps using T sub C. Let's take a look at the question again. We randomly selected 36 cars with the same model, and we found that the sample mean is 9.75 days. We found that the sample standard deviation is about 2 days. We have sample standard deviation. We don't have sigma. Sigma is missing from past studies. For any reason, they didn't calculate the population standard deviation. This is the first time they are dealing with this. So we cannot use ZC. There is no way we use ZC. We have to jump into the second guidelines and use T sub C and T distribution. Very good. So what are the guidelines? First of all, it says verify sigma is not known. Well, from the fourth line, we see that the sample standard deviation is given. It's not the population standard deviation. So that's why we are following T sub C, T distribution. The sample is randomly selected. Yes, we randomly selected 36 cars. We don't have information about the population being normally distributed or not, but we know that the sample size is more than equals to 30. We selected 36 cars. So N 36 is more than 30. We're good to go to the second step. Find the sample statistics, N, X bar, and S. N for the sample size is 36. X bar is the average, is the sample mean, which is 9.75 days. And S is the sample standard deviation, which is 2.39 days. We have all of this information. We don't need to calculate using any of these formulas. Step 3, identify the degrees of freedom, the level of confidence, and the critical value, T sub C. Very good. So what is the degrees of freedom? Degrees of freedom is N minus 1. N is 36. So 36 minus 1 is going to be 35. The degrees of freedom is 35. What is the confidence level? The level of confidence is 99%. Now we need to find T sub C. In the solution, you see T sub C is 2.724. But how do we calculate that? Let's take a look at our calculator. Using our calculator and finding T sub C. Let me share the screen with you so you can see these side by side. Perfect. So to find TC, we're going to go to second, vars, and go to inverse T. What is the area? 1 minus 99% is 1%. 1% divided by 2 is 0.005. What's the degrees of freedom? 36 minus 1 is 35. So you're going to enter 35 here. Then go to paste. Paste again. And as you can see, the number is negative 2.7238 and so on. So basically, it says that, hey, the critical value on the left is a negative and on the right is positive. But remember, you're calculating the distance. Distance cannot be negative. So we need to ignore this negative sign. T sub C is 2.724. What is S? S is the sample standard deviation, which is 2.39 days. Divided by square root of 36. 36 is the sample size. And then if you do the computation, it says, hey, the distance is about 1 day, right? So again, the units that you're calculating must match the unit in the question. The distance is 1 day. Let's find the confidence interval now. Left endpoint, right endpoint. The left endpoint is x bar minus e, and right endpoint is x bar plus e. We want to know on average for the population, what is the minimum number of days that specific model sits in the dealership lot? And what's the maximum number of days? X bar, remember that it was about 10 days. The distance is about 1 day. So 9.75 days minus 1.09 day, which is about 8.66 days. And on top, you have X bar plus E, which is 9.75 days, plus 1.09 days, which is about 10.84 days. So you can say that, hey, we are 99% confident that the population mean number of days that same model sits in the dealership lot is in between 9 days to 11 days, or 8.66 days to 10.84 days. How do we use our calculator to verify we have correct answer? We're going to go to stat, and we're going to go to tests, and then find T interval. To find T interval, since we don't have the actual data, we have the statistics, so we're going to select statistics. What is X bar? What is the sample average? It is 9.75, so 9.75. Then the sample standard deviation is 2.39. 2.39. What is N? N is 36. We selected 36 cars of the same model, and the confidence level is 99%, so 0.99. Let's do the calculation, and as you can see, we get a very close number, 8.66, 8.67 to 10.83, 10.84.